Hello, my beautiful AP Computer Science A students. Welcome to another lesson. This time in Unit 8, we are going to go over Lesson 2, which is going to be traversing two-dimensional arrays. So in Lesson 1, we talked about what a two-dimensional array was and went over how to create it, how to access the elements. Now we're going to talk about how to traverse them. So first, one of the main things we use a traversal for is to display, okay, in some fashion. So nested loops are used to traverse and access all of the elements in a 2D array. So since 2D arrays are stored as array of arrays, the way they are traversed is very similar to one-dimensional array objects. So you'll see that we use that for loop to control the indices of the two-dimensional array. Okay. So there's going to be two ways we're going to talk about traversing. One is row major, which refers to traversing the two-dimensional array by moving across the table first. So doing the rows, I think of like rows first, right? So start at the first row and traverse across. Column major refers to traversing by moving down the table first. So traverse through a whole column and then come back up, go through the next column, come back up, next column. So both of those are important distinctions because those are the two main ways we traverse a 2D array. And I'm going to show you an example of how we use nested loops to accomplish this. First off, by just displaying the contents of a two-dimensional array. And then we'll get into some actual AP examples where we actually do something with these traversals. Okay. So here I have a two-dimensional array called grocery, and it stores strings. So what you'll see there, again, is just a common format, easy to read in your code, but it represents a 4x3. Okay? Notice I have 4 rows and 3 columns, and that's just organized conveniently in my code so that it looks like a table. Okay. So my goal is to display the contents in row major order. So let me show you the code. I'm going to show you all the code right off the bat, and then we're going to break down exactly what's going on. Okay. So here's the code. Whew. It looks exciting. You're going to be working with nested loops so much when it comes to two-dimensional arrays that you'll be able to read this no problem after all of the practice we've done, okay? So don't be intimidated by it. Let's go through it. Let's start off with this first for loop header. So this is the outer loop, right? And it uses grocery.length to control how many times your variable I is going to loop. Now remember, grocery.length represents the number of rows, okay? Which means that the variable I is going to traverse through each row in your two-dimensional array. Okay, so this outer loop controls the rows, okay? And that's kind of the language that I'll be using as we go through all of these examples. It controls the rows. You can also see that when you look inside, when we have this grocery IK, I represents the index of the rows. Okay, so I controls your rows. In the inner loop, right away, the inner loop uses grocery, and then in the square brackets it uses zero.length to control the variable k. Now remember, that was the number of columns, okay? Grocery with those square brackets 0, that represented the number of columns. So the variable k traverses through each column, which again you can see here because k represents the column when you're trying to access each element, right? So inside that loop, remember, this is going to access the element, okay? It's going to access the element at index I, comma k, or comma k, but index ik, all right? Then it's going to concatenate that with a space. And remember, this is just a print statement, okay? This is just a simple print statement here. So that element gets displayed, followed by a space, and then you're stuck inside this loop until it's done, right? So the first time through, index row 0, and then you have 0, 1, 2 for your columns. Okay, so I will stay fixed at 0 while you go through your columns, right? So K would start off as a 0, so butter would get displayed, followed by a space. Then K becomes 1. When K is a 1 here, 0, 1 is milk, followed by a space. Then K becomes 2. When K is 2, eggs gets displayed. And then when K becomes 3, we're equal to the length of the grocery 0.length. So the loop stops. And then I have this system.print line and nothing in parentheses. And that just moves my cursor to a new line. Okay, so that it can, each row gets displayed on a new line. And that's outside the loop here. Okay, so there's a lot going on. Okay, I say you'll see these enough that you'll start to just kind of innately know what they mean, meaning that you won't have to necessarily trace through like a formal trace, right? Because when we've seen nested loops before, we've had to do, okay, 0, 0, 1, 2, 3, okay, then this becomes 1, then this goes back to 0, right? We call that more like a formal trace. We don't necessarily have to do that when we're working with two-dimensional arrays because traversing through them can be very predictable as long as you recognize if it's in row major or column major order, okay? So notice how I always say, look at this, the comparison, look at what's different, right? And the only thing that's different besides the I and the K, the only thing that's different is how many times it loops. Grocery.length refers to the rows on the outside, and inside is the columns. Okay, and when your rows are the outer loop and your columns are the inside loop, that is row major order. Okay, so when you traverse through a matrix, it's going to look like this. It's going to start at the 0, 0 and go through the entire row first, and then this new line gets printed, so it moves to the next row. Okay, right? I becomes 1, and then it traverses through the whole row again. Then I becomes 2, traverses through the row. I becomes 3, traverses through the row until that outer loop is done. Okay? So you have those two loops to control the two things you're looping through, right? The first one you're looping through is the columns. The second thing you're looping through is the rows. Okay? So this code, kind of bringing it all together, this code will print the following, okay? Right? It starts off as I0, K0, so it's going to print off butter. Then, when I is 0, you're still stuck inside this loop, so K becomes 1, milk is printed. K becomes 2, eggs is printed. Once K becomes 3, the loop stops, a new line is printed, I becomes 1, and now you're looping through the next row. Same pattern, bread, candy, juice, then the next one, then the next one. Okay. Now you see how this that was displayed looks, I mean, it's identical to this, right? Which is why a lot of the times you'll see the code written in row major order. And that's just because it's just innately kind of in our head. Like we read a book, we read across the page before we read down the page. That's how the code reads. So when we're writing code segments where order doesn't matter, right? When it doesn't matter if we go this way or this way through a row, most of the times they'll stick with row major order, okay? But we'll see column major here in a moment. But row major is the majority way that code is written when we're traversing through a two-dimensional array. Okay. I would say any questions, but I can't hear them anyway. So if you have questions, write them down and let me know, okay? So here's the display the contents in column major order. Okay, so before I show you the code, remember row major was going across the row one at a time. Column major is going to be doing the opposite. It's going to be starting here but going down, traversing through each column one at a time. Okay, so here's the code. It's going to look very similar to row major, but I want you to notice the subtle differences that make it column major, because noticing those subtle differences is what's going to cost you the point on the AP exam, right? So let me show you. I'm going to pause. You can pause the video to try to find the differences, and then we're going to talk about it. Okay. Did you actually pause and see the difference? Okay. So what are the small differences? Because I can still see that it's a nested loop, and I can still see elements from row major over here. So what is different? The outer loop is the first thing that you should notice is different. The outer loop now uses the number of columns. Okay. So we say the columns will quote unquote be fixed while the inner loop goes through the rows. Okay. So now I represents columns, okay, and you'll see that right here. I represents columns, so the column is going to be fixed at 0, and then my inner loop, notice how it uses grocery.length, and that was the number of rows. Okay, so we have rows and columns here. So now the rows are going to be traversed while the column stays fixed. Okay, so the first thing that gets printed here is K0, I0, but then K changes to 1, and that means that your row changes. So butter gets printed first, then bread, then spinach, then chicken, and then K becomes 4, and you've reached your grocery.length. Okay, so then your column increases by 1, your K goes back to 0, and you repeat the same steps. Okay. Now, how does this get displayed? This still gets displayed horizontally, okay? And we'll see that in a moment when we talk about what's actually printed to the console. The array that gets displayed in column major order is not the same looking array as it is right here, okay? As it was with row major, okay? Row major display looked the exact same as the code, but that's not going to be the case for column major here, okay? So it traverses through like this, what I drew over the grocery list there. But that's what it's going to look like when you traverse through that matrix. You start at the beginning just like you would on a page, right? The upper left-hand corner. But now you're going to read down. Before you move over to the next one, read down, etc., etc. Okay. So what gets printed, okay, like we said, we start at 0. Butter gets displayed. Butter, then bread, spinach, chicken. Bread, spinach, chicken, and they all get printed off on that line because it's system.out.print with a space after it. And then you move to the new line, and then you get milk, candy, peppers, beef. What a combination that is, okay? And then you move to the next column, eggs, juice, apples, pork. And those get printed off, okay? So you can see visually what's printed here does not look the same as here. It's kind of, I don't want to say traverse because we're using traverse in a different way, but almost inverted in a way, if that makes sense. And that's column major. Okay. So there's situations where we need to code row major, and there's situations where we need to choose column major. And then there's situations where it doesn't matter. Okay. Now, like I said, when in situations where it doesn't matter the way we go through an array, we usually just use row major. Okay. But if you do need to use column major, those subtle differences, you switched these two, essentially just switch these two positions, and you have to be careful of how you access the elements. So here, K represented the rows, so that has to go right here. In our row major example, K represented the columns, so K went here. Okay. So just make sure you keep those straight when you're writing that code, and those are the main differences there. Got to get my coffee, or I'm going to probably fall asleep in the middle of the video. Now, it's too exciting to fall asleep, right? I shouldn't be falling asleep. So we're going to do 2 examples of writing these traversals now to accomplish a task. So it says, using your list of groceries, just write a code segment that prints the longest word in that 2-dimensional array. So we're not writing a method here, we're just writing a code segment that still uses groceries to find the longest word in the array. Now, this is a searching algorithm, essentially, right? Which we'll define more formally in the next lesson. But for right now, just see, oh yeah, I'm searching for the longest word. So I'm looking through the entire array. And when you got to look through the entire array, you need to use a nested loop. Now, what else do you need? You need to have a variable that keeps track of what that longest word is. Okay? A variable that keeps track of it so that you can report what it is at the end of that code segment. So I'm going to start off by defining a variable called longest to be my longest word. Now, I could have set this equal to an empty string. I just by default set it equal to the first word in the first column in the first row. But you could easily set this equal to an empty string too. Okay, whatever default you want to send it to. But this is going to keep track of my longest word. If I go through the whole loop and butter ended up being the longest word, then perfect. It's already the longest word. But that's just by default what I did. Now, since it doesn't matter the order that I traverse through the 2D array in, right? I'm just looking for the longest word. So if I go across or down their columns first, I'll still go through the whole array. I don't need to go through in a specific way. So I'm just going to do row major because of that. So my outer loop is going to control my rows. So I less than grocery.length. My inner loop is going to control my columns. So I got the grocery 0.length. Okay. And now I have to find the longest word, right? How do I know if I find the longest word? Well, I want to take the element that I'm currently at and compare it to the longest word that I have. And how do I want to compare these two strings? I want to compare their lengths. So I'm going to ask a question. Is the length of the word I'm currently at longer than the length of my longest word, right? That's the question, okay? If the element you are currently at, so that's what grocery IK represents, the element you're currently at in your list, dot length, if that is greater than the longest dot length, longest being whatever stored in your longest variable, then you want to change your longest to your current element, right? So we would say longest equals grocery IK. And then I just print off what the longest word is after I loop through. Okay. Okay. So it looks like a lot of code, but remember the breakdown, right? These two loops, they just control how you're moving through the array. Okay. I represents rows, K represents columns. Once you get used to those natural loop headings, you just kind of overlook them in a way that that when you see them, you're like, oh yeah, I'm just moving through the array. I don't have to trace it. I'm just moving through in row major order, one at a time. I is my row, K is my column. Done. Okay. So start thinking like that as you're practicing the code tonight, as you're practicing the code throughout the rest of this unit, that your header is just moving through the array. Those two headers together, just moving through the array. Let's do a second one. Okay. 2, using your list of groceries again, write a code segment that finds the column with the longest word. Okay, the column with the longest word. So now here, when you are looping through, you can, it just depends, right? So does it matter if we go through the rows or the columns? Well, technically, you could go through the row like we just did, find the longest word, and then also report that longest column, right? Whatever that is. So you could go through that way. But I want you to start recognizing when we are looking at specific rows or specific columns and we're trying to find a specific index, sometimes it's better to loop through according to what you're trying to find, right? So if I'm trying to find the column with the longest word, let me loop through the columns, okay? Again, you don't have to in this specific scenario, but I wanted to do an example using column major. Okay, so just go with me, right? So again, now I'm going to use a long word, grocery 00.length. So that integer variable is going to keep track of the length of my longest word. I just want to find the column that has the longest word. I don't care about what the longest word is. And because I don't care what it is, I just made a variable that keeps track of the length of it. Okay. Again, there's going to be a lot of ways you can write this code, but this is just an example of one way you can do it. Okay, so just go with me. If you see a better way, I love that for you, but this is just one example. Okay, I'm going to have a integer keeping track of long column. So what column is this longest word in? I'm going to loop through in column major because that is what I decided I wanted to do. Okay, so I have my outer loop is going to control my columns, I, and my inner loop, K, is going to control my rows. Okay, so I'm going to traverse through my columns first. I want to check if my current element, again, because K represents my rows and I is my column, I want to check if my current element's length is greater than my long word length. Okay, because if it is, then I have a new long word. If it's not, I don't care, I move on to the next word, right? So if it is, two things have to happen. My long column is going to be equal to I. So that's how I keep track of the longest column throughout all of this, is I change it to I, the column I'm currently at when I find my long word. And then I also need to change long word, and I realized I made a mistake a little bit earlier, but I didn't change this, I'm sorry. Because I'm using long word to store that that length, I take the current element and that becomes my length. Okay. So I'm sorry, I didn't change that before, but there it is, that length. You could have easily done what I did in the last example as well, and used just long word as the word itself. But this is just another way to do it, just to kind of show you a different way. Right. And then at the end, you just print it off. I'm going to put that back there because that's kind of bothering me. That length. Okay, so that's an example of traversing through column major. Row majors by default. A lot of things you can get done just by going through row major, but a couple things you just got to be ready for with the column major. Okay, so that was using what we call regular for loops. As we know from our array unit, we also have the for each loop, or the enhanced for loop. So we're going to look at how we traverse using that. The for each loop. Okay. So remember we talked about in lesson 1 how 2D arrays are stored as arrays of arrays. Okay. So the variable in the header for the for each loop is going to represent a 1D array. Okay. Because by default, the way Java handles two-dimensional arrays are arrays of arrays. So the outer loop actually represents a one-dimensional array, which is the row of your 2D array. So you'll still use nested loops, but this time the outer loop will traverse through the rows, and it does this by defining a one-dimensional array. Okay, so remember visually we said Java stores arrays like this. These are supposed to be nested, all right, an array of arrays. So we have this outer array and then we have this inner array. So the outer array is actually a one-dimensional array, and then in that one-dimensional array we place other little tiny one-dimensional arrays. Okay, that's how Java thinks about it. So when we do the for each loop, the outer loop is going to be traversing through this outer array, which is the rows. Okay. The inner loop is going to traverse through a single row in that 1D array, which represents the columns. So I'm going to go back a second here. So the inner loop is going to go through each of these, inside array, which represents traversing through the columns. Okay, so the inner loop is going to have the same type as the elements stored in your array. The outer loop is going to have, again, the same type, but it's going to be a one-dimensional array. Right? And that always kind of throws people off a little bit, but once you get used to the syntax of it, I promise it'll be a-okay. Okay. Remember that for each loops do not use indices. Okay. No indices, no i's, no k's, no indexes at all. And just like arrays, we cannot modify elements in a for each loop because a for each loop technically uses local variables to handle 2D array elements. Okay. So remember this nested for each loop syntax that I'm going to show you, it traverses a two-dimensional array perfectly. It accesses elements wonderfully, but you would really only use this when you're trying to access elements, not when you're trying to change elements, or even if you're trying to keep track of locations, because keeping track of locations, you need indices, right? And we don't use indices with a for each loop. So anytime you need to do modifications or keep track of something, we usually don't use for each loops, just to access. Okay, so we're going to use the grocery list just because, it's the same list as before, okay? So my outer loop now is going to be a one-dimensional array. And what this says, when I read this, what I say, like in English, for each row in the two-dimensional array grocery, okay? So string, so it's the same type as our two-dimensional array. It's going to be a one-dimensional array. And that 1D array represents each row. So each time you loop through the outer loop, it changes rows. Okay? So for each row in grocery being our two-dimensional array, right? So that's the outer loop. The inner loop now, same data type. Now I actually define what the element's going to be. So I call it item, but it's the element that you access for each item in your row. Okay, row being what you defined as your 1D array. Okay, so these two words have to be the same. These data types have to be the same as your two-dimensional array. Okay, and now when you actually go to code, you just use item. Okay, item, every time it changes, it represents a different element in your two-dimensional array. So if I just, again, wanted to display it, system.out.println item, space, and then outside that loop, I have my new line code. Yeah. So that's your for each loop. Okay. Again, really good for accessing, not great if you want to change anything or if you wanted to keep track of locations. All right. The last thing we're going to talk about in this lesson is printing two-dimensional array patterns. So this is more geared towards those of you at AP. It's a common question where they ask, what is printed as a result of iterating through a nested loop? And we've practiced this before in earlier units when we were dealing with looping and nested loops. But now that we know what we know about two-dimensional arrays, we're going to revisit these questions because sometimes the nested loop questions are just that. They're just nested loop questions, no arrays needed. But sometimes, like we're going to see in a moment, they use two-dimensional arrays to try and see what's printed. Okay. So I have 4 examples here. Okay, this is going to be the first example. All of these examples are going to use this 2D array of symbols, of string symbols. And they're going to traverse through the two-dimensional array. And I want to just point out some things and help you notice some things that are going to help you answer these questions when you see them. Okay? So what I want you to notice first is how are we traversing? Symbols.length, symbols 0.length. Okay? I tell students just write it. This is the row, this is the column. Okay, write it down. Okay, it'll help you remember, okay, outer loop is rows, inner loop is column. This is going to be row major. Okay, but what's different about this? I starts at 0 here. Okay, that's what we expect. But K equals I. Okay, that is different. Okay, and that's what I have on the next slide, kind of highlighting. That's different. We haven't seen that before. So how does that change what is displayed? Okay. Well, when you go through your first time, I is 0 and K is I. So K is 0. Okay. So the first time through, it's going to print what you would expect, right? That first row. Okay. Oh my goodness. Exclamation mark, question mark, hashtag. Ooh. I can't believe I called that an I. You get it. Okay, so the first time through, I is 0, K is 0. Perfect. Then I move to a new line. Now what's printed? I becomes 1. So I'm working in this row right here. K becomes 1. Now, when I loop through and K becomes 1, that means I start here and I loop through the question mark hashtag or pound symbol. Technically, it's a pound symbol, y'all. Okay, I shouldn't call it hashtag. It's a pound symbol. Okay. And that gets printed. Then I becomes 2. Okay. What happens then? K becomes 2. So that's this right here. So a pound symbol gets displayed. And then I becomes 3. K becomes 3. And then, wait, I don't have an index 3. Okay. But actually, when K becomes 3, remember symbol 0.length is also 3 because there's 3 columns. So if K is 3 and symbols 0.length is 3, this loop actually never gets entered when I is 3 and K is 3. Okay, so we skip that. We would just have a blank line, or I would think, yeah, because we would print off a new line after that, but it doesn't show up. Okay, and then you've reached the end because now I becomes 4 and you've reached the end of your rows. So that, what you see on the screen, is what gets printed with that segment of code. Just like with arrays, there are still in array index out of bounds errors on these. We haven't seen any examples quite yet, but trust me, there are. You can't go outside of your indices, right? Just like with arrays. Can't go outside of your indexes, can't have decimal indices, can't have negative indices. All of that fun stuff still applies. Okay, here's our next one. Yeah. Notice, first thing to notice, how are we traversing? Okay, I have columns here and I have rows here. So it's column major. Okay, so I'm going through the columns first, right? And I still have that I equals K. Okay. K represents the rows, I is the columns. So when I is 0, K is 0, and I traverse through the whole column first. Okay. So kind of what's expected, 4 exclamation marks. Did not want to call them I's again. 4 exclamation marks. I becomes 1, which means your row becomes 1. Okay. K becomes 1, and when K is 1, you traverse through these 3 down the column, but they get printed horizontally. Right. 3 question marks. I becomes 2, so you're looking at the second column. K becomes 2, so you're starting here and you're just traversing through the rest of the column. So you're printing 2 pound symbols. And then once I becomes 3, your loop stops and you are done. That is what gets printed off to the screen. Yeah. So you see how I didn't have to do a formal trace there, right? I didn't have to lay out the I and the K and write it all down. You definitely could, especially if you're feeling a little insecure starting these off. That is totally fine. But work towards getting to the point where you could kind of reason through it like I did, because that's what we want. That's how you'll work through on the exam. You'll want to get to that point. But if you do have to write out some scratch work on what I and K are, feel free to do that. Okay, Now it's happening. So symbols.length, perfect. That's the rows. Ooh, this is new though. Symbols.length minus 1. Okay. What does that mean? Okay, that's still columns, but now it's columns minus 1. Because there's 3 columns minus 1. 3 minus 1 is 2. Which means I'm only going through 2 columns since K is starting at 0 now. Okay. I'm only going through two columns. I represents the rows, K is the columns. Okay. Rows stay fixed. Wait, did I mess this up? Rows stay fixed, and I traverse through 2 columns. No, I didn't mess it up. Okay. No, we're good. Yikes. Everyone good? Goldie's good. We're working on it, right? So I traverse through, I fix the row, and I only go through 2 columns at a time. So when my row is 0, I only go through 2 columns. All right. So the exclamation mark and the question mark are what gets printed. Then I becomes 1. I traverse through two columns again. I becomes 2 columns. I becomes 3 2 columns, and I'm done. Okay. I only go through the 2 columns when I have that boundary length. Okay. Sorry, I didn't mean to make you panic there. Anyone ever do that? You ever code everything yourself and then just forget about it? Doubt yourself. Here's our last example. Last example, we got some funky things going on now. I like the way this looks. I now is symbols.length minus 1. Okay. Now symbols.length, that was the number of rows. I have 4 rows. 4 minus 1 is going to be 3. So I is going to start at 3, decrease by 1 each time, I greater than or equal to 0. So this means I'm going to start at row 3, and then I'm going to go to row 2, row 1, row 0. So I'm going back. I'm going a row at a time, but I'm going backwards through the rows. Prepare yourself. K equals I again. K less than symbols 0.length, so that's the columns. That controls the columns there. So now K equals I. So the first time through, I is 3 and K is 3. Okay. Well, what's 3 and 3? Okay. That's nothing, right? There's no 3. I never actually even enter my loop here. So nothing gets printed when I is 3. Okay. Oh, look. Yeah. So now I go to when I is 2. When I is 2 and K is 2, okay, I print off my pound symbol right there, and I go through the row, but the row has already ended, so there's no more going through the row needed. Okay, I becomes 1. Okay, when I becomes 1, K becomes 1, so I start here at the question mark, and then I'm traversing through the columns. Okay, or excuse me, traversing through the row, the columns are changing. Okay, because K starts at 1 and then K becomes 2. So what gets printed off is the question mark pound symbol. And then I becomes 0, K becomes 0, so I start here, and then K changes to 1, and then K changes to 2. So I print the exclamation mark, question mark, hashtag, pound symbol. That was a funky one. That was probably the funkiest one I could come up with. But they like to get funky. They like to get funky. Okay. So that brings us to the end of this lesson. All of our practice on traversing two-dimensional arrays and all of the good stuff that comes with that. Next lesson we'll talk about algorithms, and then eventually we'll talk about methods with two-dimensional arrays. So thank you guys so much for watching and following along, and I will see you next time.